Welcome to Easy Elimo, Learning Simplified. My name is Eric. I'll be taking you through the topic divisibility tests. And for this lesson, we will be discussing about divisibility tests for 4 and divisibility tests for 5. So we will look at the divisibility test for 4. After that, we will look at the divisibility test for 5, and then we also look at some of the problems or questions involving divisibility test for 4 and 5, and then at the end we'll be able to give you some sample questions to help you with practice and just to check whether you really followed what we are going to discuss through this session. So we start with the divisibility test for 4. So we say a number is divisible by 4 if the last 2 digits of the number forms a number which is divisible by 4. So this is the condition that you'll be looking for. So your focus will be majorly on the last 2 digits of the number. So you look at majorly the last 2 digits. Like for example, here we have the number 120. We'll only focus on the 20. So 20 here divided by 4 is 5. And you can see this 20 here is divisible by 4. 4 goes into 20 5 times, meaning 20 is divisible by 4. So because the last 2 digits here forms a number that is divisible by 4, then we can then conclude that the number 120 is divisible by 4. That is the test, or that is the condition that you should be looking for to check whether the number is divisible by 2 or not. The next one is 532. We will only focus on the 32, the last 2 digits of the number. So again, 32 divided by 4, that is 8. And 8 is exact, so we can confirm that, or we can then conclude that 32 is divisible by 4. So because of the last 2 digits being divisible by 4, we can then conclude that this number 532 is divisible by 4. Let's look at 204. You only focus on the last 2 digits, and that is 0, 4. So that is giving us 1. Remember the first 0 here, we've said before in our previous videos that it doesn't count. It doesn't make any difference. So ideally, this is just 4 divided by 4, which is 1, meaning the number formed by the last 2 digits is divisible by 4. So from there, we're able to conclude that the number 204 is divisible by 4. The same applies to 3,456. So the last 2 digits, 5 and 6, forms a number which is 56, and 56 is divisible by 4 14 times. The same applies to 3,428. We are concluding that it is divisible by 4 because of the last 2 digits, which is 28. So 28 is divisible by 4 7 times, and that is why you're concluding that that number there is the number 3428. That is 3,428 is divisible by 4 because of the last 2 digits. So all the time you only check the last 2 digits and you check whether it is divisible by 4 or not. So if it is divisible by 4, I mean the number formed by the last 2 digits is divisible by 4, then you definitely conclude. So if it's not divisible by 4, then you will conclude then the number is not divisible by 4. So there is an example here to help us with the understanding of the concept. So the question is, which of the following numbers is divisible by 4? So we'll only focus on this. So maybe you can try and check whether this number is divisible by 4 using the long division. So we have the division sign, and then we have 4 outside, and then we have 2, 3, 4, 4, 5. Remember, we'll only be able to conclude that this number is divisible by 4 without doing the test if you have to use the long division method, if the remainder will be 0 here. After we are done with the division, and we keep subtracting, and then whatever will be remaining down here will be 0. Then we'll be able to conclude that the number is divisible by 4. With that, I'm not using the divisibility test. We're just using the long division method to confirm that this number here is not divisible by 4, because now the remainder here will not be 0. So if you realize the remainder is not 0, then the dividend is not divisible by the divisor here. So let's see. Like in this case, if you use the test, 45, the last two digits forms the number 45, and 45 is not really divisible by 4. So we want to see whether that can be confirmed if you use long division method. So let's see. So as we have seen in the previous videos, you have to check whether the first digit is divisible by the divisor. So this is smaller, so it's not possible. So you pick the first two. So 23 divided by 4 is 5, and 5 by 4 is 20. Then we said you simply do the subtraction. Take note of where I'm writing that. Take note of where I'm writing the 5 on top of the second digit of the 2. So if you subtract this is 3. This one subtracted will be 0, so I don't write it. So we just drop this down, and 34 here divided by 4 is 8, and 8 by 4 is 32. So you subtract again. This is 2. Then you drop the next 4. So 24 here you divide by 4 is 6, and 6 by 4 is 24. So if you subtract, this will be 0. So you don't write it. So you simply drop the 5 down there, and 5 divided by 4 is 1, and 1 times 4 is 4, and you can see that there is a remainder of 1 there. So you're able to confirm that this number, the number 23,445, isn't divisible by 4. And you can also confirm, if you use divisibility test for 4, the last two digits, 4 and 5, forms a number 45 and 45. You can tell, you can be sure that that 45 is not divisible by 4. So whether you use the long division or you use the divisibility test, you're supposed to be arriving at the same point or the same conclusion. So here, the long division method will take a whole century. So that is why it's better to use the divisibility test. That is easier, less tedious, and just within a very, very, very short time, you shall have arrived at the conclusion that the number is possibly not divisible by 4. So now that we have seen that in the first case, then we don't need to do it in the second case, because now we know. So we only check the last two digits of the number. So 53 here is not divisible by 4, and therefore we are able to conclude that this number is not divisible by 4. So when you go to the next one here, 3,456, you can see the last two digits forms a number 56, and 56 is divisible by 4. You take 56 over 4. So 4 here, 1, 4 goes there, 1, remainder 1. You take 1 to the next digit as 10, 16 is 4. So 4 goes into 56 14 times, or you can use the long division if that is not really interesting. The long division, we have the, so this is 4, this is 56. So 4 goes into this first digit once, and 1 by 4 is 4. Subtract is 1, and then now 4 goes into 16 4 times. 16. So you can see now 56 is now divisible by 4, because the remainder down here is 0. So 56 is divisible by 4 because the remainder down here is getting to 0. So because the last two digits of this number forms a number 56, and 56 is divisible by 4, then we can conclude the whole number 3,456 is then divisible by 4. So this is how you'll be able to frame the answer. Because how do you then frame the answer? How are you supposed to express the answer? Because the question is, which of the following numbers is divisible by 4? So you'll write 3, 4, 5, 6 is divisible by 4, since you restate the condition. So the last two digits forms a number 56, and 56 is divisible by 4. So that is the only reason that the last two digits formed the number 56, and 56 is divisible by 4. So you simply restate the condition that is set for a number to be divisible by 4. So that's how your answer is supposed to look like every time you come across such a question in an exam or in short tests like a rat or cat or any other test that is given. So supposedly you wanted to prove that this number, remember that is not the question. The question we are asked here is to highlight which of the three is divisible by 4. So we have highlighted this. This is divisible by 4. So if you wanted to give reason why this first one here is not divisible by 4, then the answer would look like this one here. So 2, 4, 2, 2, 3, 4, 4, 5. That is 23,445 is not divisible. So it's not divisible by 4 since the last two digits. We simply restate the condition necessary for a number to be divisible by 4. The last two digits forms a number 45, and 45 is not divisible by 4. Remember, there are instances when you'll be told to prove whether or not the number, or to state whether or not a particular number is divisible by 4, giving reasons in each case. So you can't say not divisible and then you just leave it like that in that case. So in such a case, you'll have to state the conclusion that the number is not divisible by 2, but then you have to give evidence why you say so, why you think that number is not divisible by. So when you are told to give reason why you feel it is not divisible by 2 or it is divisible by 2, then you have to restate the condition that is necessary for a number to be divisible by 4. So if you are asked to state whether or not the number is divisible by 4, then you restate the condition that is necessary for a number to be divisible by 4. Like in this case, we have said the number 23,445 is not divisible by 4 because the last two digits forms a number 45, and 45 is not divisible by 4. So there is the second example. We have the second example here. What is the smallest positive number which can be added to the number 2,345 to make it divisible by 4? So as we have the number 2345 by inspection, for this number to be divisible by 4, this one here has to be 848. See, so what do you need to add to this to make it 48? So you can talk of let the number be m, so that 2345 plus m should be equal to 2348. So our m is going to be 2348. We subtract 2345. That is 2,348 minus 2,345, and that is giving us 3 as the smallest number that is needed to be added to the number 2,345 to make it a number that is divisible by 4. Because if you have this number here will be divisible by 4 because of the last two digits, 4 12 times. Now let's look at the divisibility test. Let's look at the divisibility test for 5. So what is the condition that is necessary for a number to be divisible by 5? So we say a number is divisible by 5 if the last digit is either 0 or a 5. So 5, you'll only check on the last digit of the number. An example is 10 here. You see the last digit is a 0. So either it is a case of either or. So either the last digit should be a 0 or it can be a 5. So like 10 here is divisible by 5, and you can see the last digit is 0. The last digit is 5, 0, 5, 0. So all of them are divisible by 5. The first example, we have the first example here given. Which of the following numbers is divisible by 5? So you only check the last digit whether it's a 0 or a 5. So like the first one is divisible by 5 because the last digit is a 5. Here, no. This one, no. So you talk of the last digit is neither 0 nor a 5, so this is not. The last digit is neither 0 nor a 5, so this is not. But answering the question is which is divisible. So you'll highlight the one that is divisible in answering the question at hand. So 23,445 is divisible by 5 since the last digit is a 5, or just say the last digit is 5. So it's divisible by, so the number is divisible by 5 since the last digit is 5. Remember, this is one of the conditions. So you only need to restate the condition. The condition is that the last digit should either be a 0 or a 5. So the fact that it is a 5, we're able to conclude that the number is divisible by 5. So we are sticking to the question that is asked. We are supposed to highlight which one is divisible. So it is this one, and we have given the reason. So you don't just say this and then you don't give the reason. All the time, remember to be giving the reasons why you arrive at such a conclusion. So we say 23,445 is divisible by 5 since the last digit is a 5. So again, what is the smallest positive number which can be added to 2,341 to make the number divisible by 5? So we have 2341. So, sorry, 41. So you only need to check the last digit should be 5. 5. Remember, positive meaning some number needs to be added to this last digit. Yes. So if you had something like 9, you'd have desired to make it a 0 because the last digit can either be a 0 or a 5. So maybe you'd have decided to make it a 0. Now, what do you add to this to make it a 0? But now this is 1. So making it a 0 would mean that you'll add something like 9. That's why you're talking of the smallest. So if you add 9, that would make it a 0. That would still make it to be divisible by 5. But in this case, adding 9 and adding something like maybe making this number to be 5 would be easier because you simply need to add 4. So we have 1. So let the number be n. So plus n should be equal to 2,345. So n should be equal to 2,345 minus 2,341, and that is giving us 4 as the smallest positive number that needs to be added to 2,341 to make it divisible by 5. So that marks the end. There is some few questions here to help you with practice, just to check whether you've been really following through our subtopic of discussion. So we have the first question there: which of the following numbers is divisible by 4? Something is missing there, so it's by 4. And then question 2: which of the following numbers is divisible by, again, it's missing there, so by 5. And the numbers are listed there. You should just be able to attempt, post the response on the comment section. You'll be able to look at them and then give feedback accordingly. Otherwise, that marks the end. Goodbye.